Hey everybody, this is Larry. This is me doing virtual contest, weekly contest 448. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's virtual contest. Yeah, I'm still trying to catch up. I've been, traveling, even though it's been like a week ago. But, these things are long, so I have to kind of, get through them slowly. But yeah, all right, let's get started then. I might work on anything specific, not really. I'm just trying to be, getting through it. Few silly mistakes, more patient, and just solve them all as much as I can. All right, let's go. 448 virtual. Let's 1, 2, 3, go, go, go. Do. All right. Okay. Yeah, okay, fine. Three, 4, 8. Let's go. Don't forget any weird things. No, 0 should be the min. Alright, let's go. Wasn't sure. Easy. I'm spending like an extra couple of seconds just so that I don't waste 5 minutes penalty. But I don't do it always correctly, so we'll see. Anyway, alright. 2 n. Ooh, 2. What's n? N could be 10, so that means 1,000 by 1,000 grid. Alright. Grid is special. We satisfy all numbers on the low. All numbers on the upper or top right are smaller than the numbers on the bottom right. Right, I'm going to draw this out. Alright. Oh, and it's recursive. Okay, so so top right, it's going to be the smallest. Bottom right is the second smallest. Bottom left is the third smallest, and then top right. Okay, so 1, 2, 3, 4. Okay. Yeah. Okay. So there's gonna be 1,000,000. I kind of want to do this. Yeah, I kind of want to do this recursively, but maybe it's fine. Yeah, I mean, I think you're supposed to do it recursively anyway. But okay, fine. Right, so here. Okay, so if x is equal to 1, is it 1 or 0? If 0, then it's 2 to the 1. Okay, fine. If it's 0, then we just return. Okay. Okay, and then otherwise, we do the 4 quadrants, right? So, okay, and then otherwise, g is equal to say g of x minus 1, g for grid. And there are, so if x is 1, if x is 1, then there's 2 by side, so it's 4 elements, 2 by 2. So it is going to be, so each one of these is going to be 2 to the, okay, so 2 to the x minus 1 size for each of these, right? So that gives us the offset. Okay, and then r is equal to, let's say none times I wrote this a little bit awkwardly. L is equal to right, and then smaller L. Okay, right. So then now we have L for right, and then we return R, say. So then now we want. Okay, right. So then upper right. Is going to be okay, for I in range of smaller L, for J in range of smaller L, we want to say G or R of the, so I plus J plus smaller L is equal to G of I. No, this isn't right. It's not smaller L. This is. No, I guess this. L is the length of one side. So smaller L. Okay, yeah. Length of one side. I don't know why I wrote it this way. Just put L2, say. Versus. Okay. G of ij, right? And then lower right. Guess we just do the same thing, really. But then now the offset is plus L2. Is this plus offset is going to be L2 times L2? Okay, fine. Right. And then lower left. Same thing. Offset is going to be this times 2. Except for now it's going to be on the row. So, okay. And then finally, upper left. Yeah, is that right? Okay, I think that's right. This one is just whatever. Okay. Right. And then return go and I think that's it. Alright, let's take a quick look. 3021, okay, 5th. 30, okay, so it looks okay for that one. One more thing I would have is just like performance, so let's kind of run it real quick. Maybe it takes, okay, I mean, let's give it a YOLO submit. Okay, good. That was a little bit slow, but I don't know. How much time do I have left? That took like 6 minutes. Okay. Alright. We have 2 hearts, do we? Okay. Well, straight row, integer n, integer k. There's just a lot of random integers. Position and time each of length n. Position list the position of signs in strictly increasing order. Okay, fine. Time represents the time to represent. Okay, fine. You must perform k-merge operations. In one merge, get 2 adjacent signs and update the sign so that its time is. Okay, this is a very weird way to put it because updating the sign shouldn't update like the speed, but okay, fine. After exactly k merges. Alright, what are the constraints? Constraints seems okay. L is 10 to the 5th, and that's the no. Position is the signs, right? So L is just the number of kilometers. Huh? Where does L come into play? L doesn't even come into play, right? Okay, it's just, well, maybe not direct anyway. Okay, so after exactly k merges. Okay, so here, position we have, Oh, after the merge. Okay, so if this after the merge of 3 to 8. Oh no, wait, 3 to 8. And then now the time is 11. Okay, is there what is Q4? Okay, well, how am I doing on this anyway? I didn't really look at the time. I just look at Q2 time because I don't want to cheat too much mentally. Okay, N is 50 is interesting. K is 50. So what's N again? N is the number of signs, okay? K is the number of merges. Sum of time of I is 100. I don't know how that means or what that means. Times of I is equal to 100. What's times of I again? Oh, the length of time. Well, I mean, this one is maybe more important, but okay. Oh, so then you do state on it? Can you? Can ya? I mean, this is clearly set up to be dynamic programming, but so we have to figure out merge and not merge, right? So okay, so let's say we are at, so dynamic programming, we go, okay, so we are at index on the position, on the signs, K left, seems like we have to. Is that enough? No, because you could keep merging, right? So that's fine, right? So maybe the current merge? I don't know. I don't know if that's right, but it's only total time can only go up to 100, so that's why I want to maybe take advantage of it. And then now it becomes take no take 100 cube. Well, not even it is 50. This is 50 times 100. Maybe that's fast enough. I mean, that's fast enough, but maybe there's a way to do that enough. Okay, right. Okay, so if index is equal to n, what is the base case? So we're done. We are currently at maybe we haven't traveled yet, so this should be maybe the left index instead of the current merge. I mean, they represent the same thing, but the math is a little bit easier, right? Maybe, I don't know. Start index, and then now it just becomes okay, so the time, the speed, if you will, is equal to start index or something like this. I mean, it's not quite right. All the way to the end, right? So like so in this case it would be all the way to the end, so maybe like n is this, it's not this, it's p what's it called, prefix maybe. Okay. We have to do also k left is equal to 0, I guess. Return minimum time, so infinity, right? Okay, prefix we'll just set up for t and no, that's fine, time. right? And so this is the speed. The starting location would be position of start of when. So okay, so then now it's just L. Let's just pick L. What's this small L thing? L minus the start times speed, right? So that would be the rest of the way. Okay, I think that's a good base case. Okay, then now it's take no take, right? Take no take, so we're at merge, no merge, let's just say no merge. Then here where best is equal to infinity, best should we just go index plus 1, we don't merge, so we do start it's just start plus 1. Well, it'll be index plus 1 anyway, so we don't merge. So that means that we end our current position, so then, okay, fine. Right? And then k left doesn't change. I think this is technically... No, it's fine. We do it, no. That means that we're done to position index up to that sign. Right, okay, so we're done up to that sign, so then we now get the cost. So cost, right? So what's the cost? Cost is equal to same thing really. So we go up to the index in time. We go from the start, just by definition, right? And then we times it by position of start. And that should be good for the no merge. I do want to point it out real quick just to see, but okay, fine. I just finish it. Okay, so merge. The cost is going to be free-ish. We just delay the cost. Index plus 1, we always do. Start, we just keep start. K left minus 1. And then that's it, right? Kind of. We have to do if k left is greater than 0, and that should be good actually. In structure, I don't know that this is right. We start at the 0. I don't. I have to make sure. I don't. This. I think the structure is right. I don't know that the setup is right. Okay, so I mean, and we are not correct yet. And in the, I feel like I'm missing the start. So start at 0. Oh, because we start at 0, not position 0. How do I change that? Oh, position. So there's always a sign at the first one. So okay, so we are always at 0, and so that's fine. Maybe that fixes that. So start is always going to be 0. We skip the first sign. Do we skip the first sign in this way? Okay, I'm just running through the code. Because basically, if you don't merge the, it's not merging the first one, right? You don't merge the first one. The first one doesn't. So this one doesn't make sense. I think it is. Maybe we're at 1 and we're trying to decide whether we want to merge it. Okay, that's really wrong in the wrong direction, but I think that's more similar. We just have to figure out maybe the cost is wrong more than that. Okay, so 1, so we start at 0. Okay, let's do something even base. Right, okay, it's 10. We have, what is that? 2. What is k? K is, can k be 0? K could be 0, so let's just do k is equal to 0. We have 0, 10, and then maybe, I don't know, 1, 1. I don't know. Right. What's the answer there? 0? That's definitely not right? Because with no merge, what does a merge do exactly? Two adjacent ones update the sign. Oh, I has to be greater than 0 and also not the last one. Okay, that makes sense, because I was like, how do you do that? Okay, fine. Something is off for me. I'm definitely not being precise on this. I think the idea is right, but I'm not precise enough. Okay. Right, so if maybe this is if index is greater than 0, you don't merge on the, because there's no merging on the first thing, and we don't merge on the last one anyway, so that's just calculating the thing. So okay, maybe give it a spin. Okay, it just gives me infinity because we don't ever do this, I suppose. Well, this one should be like 10, right? So it goes 0, 0. Okay, let's walk through it. That's what happens when you're not precise. Okay, because index means too many things for me. I think that's where I'm not precise about. Okay, so because this doesn't do this or this. Well, no, this doesn't make sense. This part I have to do index is greater than 0. So you always no merge on the first one. So then now this, yeah, we go to the first index, start at 0, k left, the cost, this would be 0 anyway, right? Yeah, this should be 0, right? So that's fine. Okay, and then the base case is wrong in here, right? So the speed is equal to the sum of that. Is that right? No, this is, well, no, that should be right. But this assumes that we merge. Is the no merge wrong? The no merge seems wrong. We want actually to go this distance, right? Also, this is wrong. I don't know what position start means. Maybe this is wrong too. Okay, yeah, no, this is definitely wrong. What am I doing here? That doesn't make any sense. We want to move position of index minus start, right? So that's the delta, that's the distance. Oh, sorry, how many? Yeah, and the speed is kind of wrong. It's like an inverse speed, so I'm lying on that one. But yeah, okay. So that's the length. This is the length. We don't merge, then we go to the next one. So here we should be doing this, and with time, prefix time. Maybe this. Maybe that's fine. Oh, index plus 1 as well. This index plus 1 could be L. Do we do it on the no merge or do we do it on the merge? I'm not consistent here either. On the no merge, you definitely need to clean up. So if you go to the next item after merge, okay, well. I think this is index plus 1 actually then. This is still out of bounds though. Wait, why is that out of bounds? Oh no, yeah, because index plus 1 should be, let's give an index. Okay, let's think precisely what this is, right? So this is time. This is the distance. But okay, so let's say you have 1. So this is 10, this is 0, no. Well, you don't want to, okay. Struggling a lot. Okay. The states are right. I think everything about this is right, except for I'm not handling the core part of the problem correctly. I think this is probably right, just because there's no way to be wrong, but the merge is not right. Okay, so what happens when we merge? When we merge, we basically skip the sign and then we accumulate, right? Maybe I could just do accumulate here instead. Yeah, maybe the prefix sum was too fancy. Okay, so we have accumulator of the time required per kilometer. No, but then you still need. I mean, yeah, that's why I did start, because you accumulate both on time and distance, right? Because you haven't traveled yet. Or can I do the math? No, you can't. So then you have to start. So you start at 0. Okay, so let's say you're at index 0. You want to say no merge with the next one. So then now you have to travel to it. Okay, I think the base case is wrong then, because then we cannot compare it to the next one. So this is the last one. So that's why I'm okay. I think this is where I was struggling a little bit. Okay, as a result, yeah, and I think the speed is off by. Oh no, maybe this is now fixed. Okay, let's see. Okay, so now we're very big. That's fine. Maybe I'm just off by 1. It looks big, but okay. I want to just return to 0 here real quick, just to see what the impact of this one thing would be. So this 10 is correct, actually. So that's what we want. So at least, I guess we're at the end, and we don't need to. At the end, we have to finish the merge. No, I guess it just assumes that. Okay, so we're at the last one. If k left is 0, we go infinity. Otherwise, we don't have anything to compare to. So I think this is right, actually. Okay. Wait, is that true? No. This is only true if start is. I think this is this bit. 1092. Okay. I mean, this is only true if start is index, right? So okay, if start is so that means that okay. Okay, I think this is true. But then now, if start. Oh yeah, and this is just wrong. Should be. Oh no, it's wrong. This is wrong, but because we have L minus S. The last one is always L, right? They say. Okay, so we don't even need L. We don't care about L, because it's just the last position. So then this is. Yeah, I mean, I think this is right. Right? Why is this wrong? Okay. No, I guess it's the same. Maybe I just kind of had to. Oh, I just had to fix this part, I think. Okay, so maybe this part is right, even though I wrote it very awkwardly. Okay. 34. I have 38, which is good. It means that we're wrong in the correct direction, because that means that we have to remove something. How much time do I have? 1 hour. Okay, that's fine. Okay, it's time to tweak around this one. Okay, let's just make this 2 for now. Okay, so that's good. That's what I expected. Okay, and then now let's put in extra thing where we can merge at one, but we're forced to, okay, let's actually force to no merge first. Okay, same answer, which is what we expect. And then now let's say we have to force one merge. So either we go 19 seems wrong. No, I see. 19 is right because it merges here. No. If we do this merge, that'll be 10 and 2. So I am doing it wrong. My logic is wrong. Because if we merge these two signs... Oh wait, no, you can merge to the end. Okay. So you can merge to the last one. Wait, can you? What is n? I plus 1 is less than n. Can you merge with the last one? It's actually unclear. So you can choose I. So you can merge with the first one. And you cannot, but you can merge with the last one, right? Why wouldn't you always just merge with the last one? Because then you don't use it. Kind of confused now. Because can you just merge 8 and 10, get rid of the 8, and then now this is 9? Right? I guess you can merge the last one. I think this is a little bit off, or am I just confused? Maybe I'm confused though. Because n is not the index, right? Because it's 0 based, so I don't know. I think you just can't merge the last one. Okay, we can merge to the last one, then maybe we have to do something like if index plus 1 is less than n. Okay, still 19 though, so, and the answer didn't really change. So maybe that's fine. And maybe this is okay. No, it still thinks you can merge with the last one though, so I don't know. This is very weird. Okay, but maybe that's just really wrong. I don't know. It is very weird, and I feel like I have to mix this minor adjustment to this problem, or solution rather. Okay, 19. Why is this 19 though? I guess you combine this one with this one, so then now... No, you can't combine the 0. So what are you combining with? The 1 and the 10, right? And then now this is a 2. But maybe I misunderstood this. Times of I. Like, we don't use the 6 here at all, so... I'm really confused why you don't combine the 8 and the 10. This is such a... Leetcode is so bad at this sometimes. Or maybe I'm just so bad at it. Okay, I mean, this is right. I don't get how is 19. One merge. You can you even do one merge? I guess you have to. k is n minus 2. Oh, also k is at most 10. So maybe I am wrong on this. Or like there's a more optimization here on k. Because for some reason I thought k is 100. Yeah, I think I'm just confused on this entire problem. Why is this 19 though? Oh, well, in my code it's 19, but it's 19 because we don't merge, we merge. We merge, but we gave it the 2 to this index. So we merged, but we added incorrectly. Okay. So how do I represent the merge? Okay. I'm understanding the merge incorrectly because you don't merge it forward. Because what a merge does is that it allows you to keep going at the speed that you were going, but accumulate it later, right? So what does that look like? So the state is wrong, I think. Okay. Because okay, I have to think about this. Jeez. How much time? 57 minutes. So basically we have skip, no skip still. We have the current speed. Okay, let's just do it really dumb for now. We have a current speed, right? And then we have accumulated speed. Maybe that's fine. So that now this is going to be 50 times 100 times 100 times 10. Maybe that's a little bit worse. I don't want to save this code, but I think it's fine. All right, let's just put it. And maybe there's an optimization here, but I don't know, right? Okay, so then now if index is equal to n, or n minus 1 like we said, then we're done. If k left is great, okay, so that's fine. Otherwise, then we are done because we're there, so we don't have to worry about it. And then now, and then now we use the new speed, and the new speed is going to be okay. Let's just use the old speed, and when we use the old speed, then now, so we're at okay, so yeah, we are at position of index, and now we're trying to figure out whether we want to use, so okay, so current position, okay, right? And now we want to go to the next position, right? So it's position index plus 1, and we want to choose, so this is the delta, right? This is the length of time, and we want to go, okay, we want to either use the old speed, and if we use the old speed, it's going to be go index plus 1, so the current speed, accumulated, we have to add times of index, and then k left, because we merged it, so minus 1, so if k left is going to do, right? So best is equal to f min, best, go this, plus the delta times current, right? Okay, so then now we want to use the new speed because we don't skip. So okay, so use the new speed. It's going to be accumulate. New speed is equal to accumulator plus time sub. Yeah, okay, time sub index maybe? I think we... Is it? Oh yeah, I think this is right. Maybe not. I don't know. Best is your fmin. Okay, best go index +1. This is the new speed. No more accumulating. K left, right? And then plus delta times new speed. Alright, maybe that's right. I don't know. And then now we go from the we do a question of first index. The current speed is going to be time sub 0. Accumulator 0. K left is right? 0, 9, 47, 26. I mean, we're missing something, but that's fine. Because this should obviously not be 0, right? So we go to the first one. We go, okay. Is it 0? Maybe it is 0. I don't know if that makes sense though. Use the old speed. 10, 10, 62, 34. I mean, okay. I mean, this is right. And I think this is right for that. So, alright, YOLO, let's go. Actually, I lied. Let me make a big case for a second. But I guess that was it. Okay. Let's see. What is the big case? L is 10 to the 5th. I guess that's fine, right? Like, that shouldn't change anything. I don't think we do anything funky there. Actually, in fact, I mean, this lies anyway, because it's in the last thing, okay? We don't use prefix, do we? We don't use this anymore. But I do want to say, well... whatever, plus 10. Okay. And then K, we just set it to 10. And I think that's it, really. Well, position and time. Okay. Okay, so the running time complexity seems okay, maybe. But I actually, I forgot that I have to do this thing because Leetcode is cancer. But okay, so I don't know if this is right, but it should be fine, maybe. I don't know. We'll see. YOLO submit. Okay, well, at least it didn't time out. I spent so much time making sure that it didn't time out. But okay, so what does this mean? I put a better answer than it is expected, so that's actually pretty not great. How much time do I have left? 47 minutes. Okay. Okay, so we have 4. We're trying to do. So we merge. Oh, only one merge. What would be the merge? So we merge from 0. Yeah, how do I write this? Okay, so 0 to 1. No way you would merge on. Well, you can merge. So go to 1 on 1. So okay, so the fastest speed on index is going to be 1. Okay, and then now 2. Did I forget like a K left is greater than, no, I do have a K left is greater than 0, so okay. Why would I do faster then? Okay, so let's say K is 0. What would the answer be? The answer is 6. That's actually weird. Okay, is that true? Maybe that's true actually, because it's just 1 plus 2 plus 3, so 6 makes sense. But then merging 1, okay. So you can only merge 1 and 2. Right? Is that true? Well, there are only 2 choices, merge 1 and 2, so then now you have 0, 3. Okay, I guess we can do this manually actually. Well, not manually, but with a test case. Okay, so that means that you have 0, 3. So if you merge these, then right? What does that give you? Is it 7 or 9? Huh, this gives you 11 even. So that's even worse. Okay, and then the other one would be if we merge to the 5, so then now this is 2, right? The merge, I think technically this has a number. So this is 9 and 7. So how do I get... Okay, so definitely wrong because... Okay, so both of these cases we have 11 and 9, but we put 7. Why do I have 7? Do I accumulate too much or something? Delta new speed, use the new speed. So what's the right one again? So 9 is the... So we want to merge it with the last cell. So we want to... We use the new speed twice. And then we use the old speed, right? Current is wrong. Use the old speed, old speed. No, this one should be right. What is current? Current speed, right? So new speed is the current speed, accumulating is 0. Should be right. Okay. We're close, but dumb on something. What am I doing? What am I dumb on? So, okay, so now we're at 2. We go, okay, do we use the new speed? If we use the new speed, I don't know. It should be no speed, and then is this off? No, this should be right. This is more like the previous speed, but okay, whatever. What, why? Is my min wrong? No, I mean, we're doing 7. Where do you get 7 from? How do you even get 7? Am I doing the 0th number wrong? 0, we go... Okay, so we use the current speed, or we use the new speed, which is the same thing for 0. Okay, so I think after the first number doesn't matter, and then now... And then now from 1 to 2... Yeah, okay, fine. Let's just print it out. This is too many states, but I hate it. Okay, fine. Okay, so this is 7, right? Because debugging sucks. Okay, so 2300, what does that mean? At the 012, the speed is 3 because you merge. Okay. What's this happening again? The speed 00. Okay, so you have to use the new speed, and that's fine. Okay, so this checks out, even though you wouldn't take that path. necessarily. Okay, 1 1 1 1 1 is 6. I think this gives rise to this, but which makes sense. But okay, so why is this 6? Because 1 1 1 0. What does that mean? 1 1 1 0. This is parsing index plus 1. Maybe my indexing is a little bit wrong. Okay, let's actually think about it. Let's do it this way. I think my indexing is a little bit, I mean, it's fine, but it's just not precise as I want. Use the old speed as current. Does this fix it? Let me just run it real quick. Nope. In fact, it got more things wrong. Well, I don't know. We didn't do it all the entire way. Okay, so now this is looking at the past, and then, but this time, and whether we should use it, right? So this is the delta. We go, okay, we should use the old speed, and then accumulate the current time index. Why is this wrong? Use the new speed. What is the new speed? It's too confusing for me to change. Let's go back to here for now. I mean, I might have missed a part. Anyway. Okay, so this is why this is wrong. But what's 11106? Let's just put it. Getting too confused. Okay. So index, the current speed at the current index is 1. Yep. Accumulating is 1. Okay. Is that true? Actually? We used the old speed, so we accumulated. No, this is not 1. This is okay. I mean, it's slightly better, but it's still wrong, clearly. And now the other stuff is wrong too. So, wait, is it? I mean, it is, but it is spinning the other way. So, why? Maybe this is here, this one. Okay, that's just wrong. I have to think of, I'm not precise on this problem, and that's what's biting me. This is right again. Okay. Why is this 6? This is 6 because it gets from 1 to 5 in speed 1. What is this input again? No, it gets from 2 to 5 in speed 1 because it. Okay. I can't keep on scrolling up and down. It's just I need a second monitor or something. But okay, let's just do it here. Okay. Okay, so we 2, 3, the current speed. This, okay, so that returns 3. That sounds right. We're going from 2 to 3. No, wait, does it sound right? We're going from 2 to 5 at speed 3. Is this right? I'm spending too much time on this problem. I should have gotten it by now. Oh, actually, this is more right. Right? Except that's 1 left. So it didn't do any merge. Okay. So if it does a merge, it does it 3. Where does it do the merge? 2. The current speed is 3. We have to use the new speed. And what is the new speed? New speed is 0 plus 1. But did we merge? We did merge. We merged the 1 to the 2. So then the 2 is the... Yeah. So where do you get this? So this is the input for 0, 1, 2. We're here. We're going, okay, we're going from 2 to 5. We could go either at 3 or 0 or at 1, but we can't. Now the current speed is 3, or we can use the new speed. So the old speed is 3, but is that old speed? No. Old speed of being 3 is wrong. New speed should be 3. Or, well, yeah. New speed should be 3 because of... so this one is right. But how did we get here? Did I miss counting? We get here from here. Okay, so index 1, current, let's put this. Okay, so this is index 1. Current speed is 1 from the previous. Okay, that's fair. The accumulating is 1. The accumulating is wrong. With index 1, we're comparing to these things. So, and the current speed is 1. Then the accumulation is going to be 2 because you skipped this. I think this is more right, but I think for some reason, where am I? Where am I? Line 9. Okay. Maybe the decorator on the comment is wrong. Okay, so this is more right, but this is going to be the wrong answers on these two. That's for sure. So maybe it's not more right. Okay, so we're now back to here. Okay, so we're here, and this is by merging them, merging the other two. We go okay, because we skipped this one. The current speed isn't. Wait, am I messing this current speed wrong? Use the new speed. So we use the new speed. Is the new speed right? From here, are we calling it right? So okay, so that means that we're here. We want to travel one space, and then we go, okay, well, we go to the 2, but the new speed is going to be, the current speed is going to be, no, that's the accumulator speed, not the current speed. So this should actually call, no, but then you went out of K left. Okay. Okay, so you have 0, 1, let's start over. 0, 1, 0 with 1 left, that's basic. Okay, that's fine. And then this course here, for using the old speed. So the old speed is going to be 1, so we skip this one. The accumulator is not 1. Despite, okay, so even though this gives, maybe it's giving me a little bit of luck, but this is not right, because the accumulator is not, so we're here. The accumulator is not 1. This is, yeah, okay. I think this is for definitively more correct, even though it gives us more wrong answer on the other ones. I think that's okay. I think I'm pretty certain on this one, but there's more silly mistakes, so we'll keep going. But it can load into this. All right. So then now we're at index here. Wait, is it? Here we have speed 4, which is also just wrong. Right, I think maybe there's some like things here that's a little bit wrong. Okay, well. Nope. Okay. Wait, is that what I'm putting? I'm spending all my time debugging this problem when I wanted to go on Q4. Okay. I think this is more right though. Okay, because we're here, we go, okay, so the current speed is 1, yep. The accumulator is 2 because we skipped 2, but we're going from 1 to 2. We want to go, oh no, then here, we just rather, because we skip, we're going from 1 to 2. This is where my indexing is wrong, is a little bit messy. I think that's why, actually. Okay, I know that I kind of, but it is what it is. I think this is more precise. Yeah, but we have to kind of make sure. There are a lot of random. I have to keep track. I think these two indexes are wrong, but we have to look at it. Okay. Okay, so delta is equal to index minus index plus 1. So then now, oh yeah, and then this goes to 1. Okay. Maybe we're definitely wrong, but at least maybe we're in the right idea. Okay, now we're at yeah, okay. So then now we are either I think this is more right, but maybe it just takes me it's gonna take me longer to recalibrate my head. Okay. Sad thing is I know how to do this one, but it's just, it is what it is. Okay, so 3, so we're here, and it returns 3, because it looks at 5.2, the current speed is 3, which sounds right. Wait, what? But current speed is 3, the new speed, okay, so something is wrong here. I think this is actually this. Or maybe this is right. Wait. Okay, so this is what we had before we we indexed it. So maybe that would have been exactly the same, but okay. But now we have to figure out why this is off by 1. Okay, so this is now at 3. Current speed is 4 is definitely wrong. Because at no point it should be current speed 4. Use the old speed, okay, and so that's definitely wrong. Okay, so 2, 1, 2, means that's here. Current speed is 1. The accumulator is 2. Oh, that's why, because this is index minus 1 on the new speed. If we want to use the new speed, it is just going to be the previous accumulator. So we're here. Do we want to? We're going from 2 to We're here. The current speed is 1. The accumulator is 2. So we want to go forward in a new speed. This should be this, actually. But now this is weird again. I know that I'm just like off by something silly, but this is so annoying. Alright, so this is at the last element. The current speed is 3. That's fine. No, it's not. How is this correct for the other two, but not this one? That means my states are not set up correctly here somewhere. Either new speed or, I mean, there's only 3 things that I'm setting up, so. New speed, accumulator. I mean, this feels wrong. Current speed should not accumulator means here. But if the current speed is 3, 1, 3, so then now it goes backwards. Yeah, no, the current the delta is already 3, so that means that it is multiplying by 1. Why? It's multiplying by 1 because the current speed, well, current speed is 3, so that would be right. I mean, it's not optimal, but it's right. New speed is accumulator, which is 0 plus 1. So the new speed is wrong. Okay, that's fine. So the old speed is right. There's no new speed, is there? For the last one. Yeah, my indexing is bad. Okay, I think I have to go back to the other indexing. I think looking forward is the way to go and not looking backwards, maybe. Okay, well, I don't know if this is right anymore, so let's just run it. Okay. Okay. Okay, so now we're back at our original wrong answer. Okay. This is 3, is that right? So we're 0, 1, 2, we're here, we're looking forward, we go, okay. Our current speed is 3. We have to go at 3. No, we can use the new speed. What is the new speed? The new speed is the one that's wrong, so okay. New speed is accumulated plus 1, so it thinks it can do 1. Oh, so no. New speed is okay. Well, the current speed part is wrong. Something is wrong. Okay, so this is definitely wrong. I see. Now I see it because it tries to use the new speed, but you can't use the new speed. Because you're given all the accumulating, right? Accumulation. But then how did you get 3 as the current speed? So okay, so going from 1 to 2, I think my states are wrong with the new speed, with the accumulation. Okay. Okay, so going from 1 to 2, you skipped it, so then now you put the current speed at 3 at the next time. Okay, let's think. Okay, going from 1 to 2. Maybe my states, maybe I'm just thinking about it wrong. going from 1 to 2. I only have 20 minutes left. I wasted all my time on this. Okay. From 1 to 2, we say, okay, well, we are not going. Oh, I think doing the delta here is wrong. I think that's the difference. Wait, okay. So going from 0 to 1, we go, okay. Going from 0 to 1, we go, okay, either we take at 1 or we take at 2. If we skip 2, then the next one is... What happens when we skip? Skip? I think my accumulating is wrong. I definitely do, maybe I do need a start thing and keeping track of it. Yeah, maybe that is the less dumb way. Because, okay, so now we think of segments instead. I think that maybe... why is this so bad? Okay, how do I want to think? Reset. Okay. Okay, reset. Okay, so then now we go, okay, we have an index. We have a starting index, maybe? Okay. Just left, right, K left, right, K left is for sure. What does this look like? Right. Okay. So what does this look like? So if right is equal to n, then we are done. Then now we want to get, well, just even n minus 1, let's just say. So then now if k left is equal to 0, I guess, then we return, well, if it's not equal to 0, then we just return infinity. Otherwise, then we want to get, distance is equal to right. I mean, this is what I had the first time though, so I'm not like super confident about it either. That's why I'm pausing. Maybe I just suck these days. Okay, well, and then we just take no tick, right? Either we think of it as segment, think of it as segments. Okay, so you have something like this, you go, okay, well, we start with 0, 0, and then we either expand the thing, and then now end the segment. Right, so take no tick. So then now we end the segment, and that is go left, oh sorry, right plus 1, right plus 1, because then now we start the new segment next, and then k left, yeah, we end the segment, then k left is the same. And then we have to add the cost of ending the segment. So ending is just equal to, why is this wrong again? Because I think this is wrong because because you don't add the right. Oh yeah, but I know, because this is wrong because when you we did this because when we merge these two, say if we merge these two, then now the segment, I mean, I think we can still do segment, but I just have to make sure I'm precise on this. Right, so then now when we merge these two, what does that mean? That means that this is the dominating number for thing, but so that means that the segment, let's just say if we merge these two to create a segment, the speed doesn't change. So this is not right. It's actually the sum of like, that's why I had current, right? Okay, fine. Maybe I had to do something like this. I don't know. And then it's the, but then is this too much? 100 left right is going to be 50-50, and then k left is 10. Maybe that's fine. I don't know. That it's tighter for sure. But okay, fine. Right. So how do we kick it off? I don't even know. But yeah. Okay, fine. It's going to be this times current. But then now the current updates to be the sum of this stuff, right? I think so. Now this is the p time stuff, so it's like almost one delay kind of thing. Right plus 1 minus p time of left, so something like this. And then now keep going, it's gonna be k left, right? So okay, so something like this, go. The current shouldn't change, so it's just current, and then left, right plus 1, k left minus 1, and there's no cost because we don't pay it yet. Right, so something like this. Okay, so then left is going to be 0, right? And then we keep going by merging, but we can't. So is this? I don't know. Well, this will always be true, so maybe that's but this seems pretty wonky though. Okay, well, got 2 right answers. I guess I'm just not solving this today. Even though I think the idea, I don't know, I said that a few times too though, so maybe that's not true. Okay, so here, keep going the current time. So we merge. We want to end the segment. Then we update the current time. Is this the right? I think this the delta is right. The current should be right if we update the current correctly. Is this right though? We want to end the segment, so let's just say we have, I mean, this is clearly not right, but one of this should be 9, one of this should be 11. Okay, base case right, so that's good. But this being 2 is actually pretty bad, right? How though? Oh, because we end the segment on just 1, 1. So maybe there's some like left right thing. No, it should be this. Someone like this, but I'm off by a little bit here. Or maybe a lot, I guess. Because you can't end a segment, but then this is the current time. Okay, so keep going. Right. And the segment, is it here? This should be right. This should be right. This part is still the part that I'm not sure about, and this part maybe even. Maybe it's right here. Okay, I mean this is a little bit cleaner, or a little bit closer, and feels a little bit cooler, but and at least these three are consistent. But yeah, maybe this. Nope. And in this case, maybe I could have gone Q4, I don't know, but definitely not getting Q3. I feel like the ideas are like variation on this. It's just that I'm struggling today. 8 minutes, literally spend my entire time doing this. Like 4 lines of code or whatever. Why is this wrong though? 10, 1, 72. So this is higher. Is this one? And this is too low. This feels right. I don't know. Am I just like? Alright, well, this I thought it would be, but okay, fine. Am I putting anything? I'm just gonna YOLO submit. Okay. Wow, I can't believe I solved it, honestly. But especially after all that, I was like, I didn't. Maybe I have to not include the one. Okay. I mean, clearly we're not going to solve Q4 in time. We have 7 minutes, but we'll do our best. We'll see. Okay, let's go. I mean, we'll solve it until after the contest or whatever. All right, mod. I should have gone that one earlier though, but I think I just kind of got confused about the offsets and stuff. Okay. Anyway, all right, let's go. It's magical if it has a length of m. Sequence of bytes is okay. That's a little bit weird, but it just means that it's part. Binary representation has case set bits. Still don't understand what this is going. Okay, fine. It's just hard to even read in general. Okay, the way product of this is you go to product. Okay, I have no idea what this problem is even asking. It's just so hard to read. But it is what it is. Maybe I'm glad I got the other one because I don't even know how to read this one. Okay, return the sum of array products for random. Okay, what's a magical sequence again? Magical sequence has length m, which we're given. The sequence of I is the binary representation of 2 to the 0 plus 2 to the 1 plus 2 to the 2 has case set bits. Okay. So plus does that mean? And you're given this random array nums. Okay, fine. Takes me. It's gonna take me until the end of the contest to even just read this problem correctly. But okay, so these are the number. Okay, I see. So this is the number of bits. So if that means that k of these. It's a little bit awkward. I mean here. Okay, so sequence. Okay, let me think. So with length n. So sequence has from 0 to n. Oh, so 0 to. What is nums? Oh, okay. So it has to be 0 to 4. Okay, so these map to the indexes. Okay. And then the representation of these. So that means that. What does that mean? That means that we pick k of these. Why don't you just say it that way? We pick k of these numbers. Wow. This is a very annoying to read problem. Okay, fine. The way product of this is product of SQL is equal to nums sub sequence of 0. So we pick what? What's m again? So we have m. So why doesn't this always have m bits? Or am I misconfusing this? Because I guess you can choose duplicates. Is that it? Okay, so maybe we can choose the same number multiple times, but it doesn't show up in here or here. Okay, 30 is interesting, but okay, right? Otherwise, okay, I guess so, because otherwise this has exactly m bits, right? If they're unique. Okay, anyway, maybe we'll ignore that for now. And then the way product of this sequence is defined as this thing. So the number that is in, so you have some sequence in some order, and then you just product it, and then you just multiply the product of these things, and then you sum it, right? Okay. I hate that they don't give you an example about this, to be frank. Like, why would you? I mean, I get it, I guess. So m, okay, so we have sequence of size m, n is 50. Nums is some big number, but I don't think that matters. It's just a. Alright, we have 2 minutes, so we're definitely not finished things on contest time, but that's okay, right? I mean, I didn't think I had a chance anyway, but especially after spending so much time on the other one. I still don't understand what I'm trying to do here, so. I mean, the only thing that this makes sense is if you can use the same number multiple times. And the idea behind that is that it's a little bit awkward. M is 30, what does that mean? 30 is 30. What does that mean? M is equal to 3 reminds me of like meet in the middle type things, but I don't know. The k-bits thing is just awkward. I think the other stuff I could probably reason out, but I'm still trying to figure out how to handle the k-bit thing in a good way. This thing is just awkward too, but and it's go to 50, so it's like 50 choose 30 sounds a little bit awkward. I mean, the idea is still going to be like try to figure out the contribution, but it's just like a product, so I don't even know. I'm going to give it an honest attempt, but I don't know that I have any idea. How many people solved this? Oh, 168. Oh, now my thing is off the leaderboard. I hate that they do that. I don't know why they time it out. I think I had a screenshot, but yeah, so here, okay. I mean, that's why they chose M and K is the same thing as the example, but I'm trying to think whether, how to kind of, okay, fine. What is M again? M is M the number of array element? M is the number of things in SQL. N is the number of bits, and there's another N that is the length of nums. Okay, so the MKN. Huh. I'm glad I got Q3 though, even if it took forever. I don't even know how to do contribution on this one, huh? Okay, so let's say, even if we get this M, I don't know how to solve it. All right, actually, maybe try to do that. Let's just say we have M and K is always equal to M. What is the solution? The solution is then just that we have N choose M things, right? In this case, this is 5 choose 2. That's why when this kind of shows up. Actually, it's not even 5 choose 2. Because the order matters. But okay, so let's say we have a bit mask. Okay, let's say there's DP and we have a bit mask. How would that look like? I guess the key observation is that when you add a new number to the bit mask, when you add a new number to the bit mask, it always either does not change the number of bits, or it adds the number of bits by 1, right? So then, so then maybe we have bit mask, we have count, number of count and bits mask for using for K, and then that's it, right? Maybe. But the bit mask can be big though, right? So that's the thing. I don't have any proof on this one, honestly, but and also we need M anyway. So we have M, we have count, okay, right? So yeah, okay, fine, like M left or something, right? So if M left is equal to 0, if count is equal to 0, then we return can I do that? I don't even know how to return in this case if it was DP. What is that? What does that even look like? Maybe 1? I don't know, but otherwise we return 0, right? Maybe? And I want to write something like this, but I don't know that that's correct. So then now if mask and if this is equal to 0, that means that there's no bit. No, I don't even know how that would work, because it can cascade. So I'm actually wrong on what I said about the observation, because you can have a thing where you add one number and then it just because you can go from, I was wrong, because you can go from like this, you add 1 to say here, and then now you go to here, right? So then that means that you, and that would use a lot of numbers. So then now the number of bit mask thing on that is not right. So okay, so I don't know that I can do it quite that way. Let's say we're trying to do index on the n, right? I'm left. This is a wild one. I don't even know how to think about this one, honestly. Yeah, honestly, I don't have any idea how to solve this one or even attack this one further. Like, how do you separate out the... And here I'm assuming m is equal to k. Am I? No, maybe not. I don't know. Alright, let's just assume m is equal to k. In that case, we have to choose m unique ones. Right? So then it's just take no tick. Okay. And then just take no tick. So it looks like this. What would the take no tick look like? So you yeah, so then you tick. I think I have an idea with just take no tick. But I still don't know how to get the sum though. I think that's the other part. Okay. Well, okay, let's say we have tick no tick, right? Then now it's just you tick, no tick, right? But then now how do you calculate the total from here? You have num sub index, that's a contributor. Is it, do you get the count? But it doesn't, it's the sum of the counts. I mean, the counts don't matter. Is that true? Like, what do we do with the tick no tick? So we have a count. Let's just say we have a count of the number of subsequences that uses this, but you just multiply them, right? So it's almost like a shift based on the other thing. Okay, I mean, we have to, okay, first principles, right? So let's say we have A times A mod M times B mod M is equal, or the other way around really is what we care for, but right. And then now count is, well, this is obvious as well, so okay, right? No, I have an extra space. So how do we use this to okay, so let's say we have a count. Okay, so what does the sum look like? The sum, we have something like this. So we have like, okay, just some random things times C. Or okay, so let's say they're unique, then okay, fine, right? But the ordering, ordering matters, but then I could say we could do a combinatorial math on the ordering, but that gets trickier once we not allow M is equal to K, or K is equal to M, right? Yeah, because then otherwise you could just multiply that by n factorial or something, so that we have sum of this. I see. So then it's the total of, because here, okay, let's say we have two paths. We have like A times B times C times D, and then A times B times C times E. To merge them, we would have something like A times B times C times D plus E, right? Or to add them, you would get this. So I think that's fine. So then now, as a result, we just want maybe something like total is equal to 2. Total, right? And then return total. I think I'm going to solve this just for M equal to K because that's the examples anyway. So we could just to see if that's right. Of course, we can whatever throw in a mod for good measure. If index is equal to n, or maybe even just like if whatever. If m left is equal to 0, then we return 1. Otherwise, we return 0. The one thing is a little bit awkward, but I think that's fine, maybe. Right, so then now we add that, and then this is this times num sub index, maybe? No. Okay, so this should be the tick no tick part, right? So tick, yep. So this is num sub index times this, and then we add it to the parts that don't. Then we sum it up. Okay, maybe that should be good. Let's see. Go 0 m. right? Okay, we have to close out parens apparently. Apparently a big thing in programming. Is that right? No, so it's not even right for this. Or even here, 28. So why is that not right though? So index. Why is this not right? So 28. This plus thing is a little bit awkward. I think. Is it just 28? What's 28 times 28? Is that where I made the mistake by accident? Maybe that is 28 square. So maybe I just made some mistake here. Oh yeah, because I have both of these whips. Okay, so maybe that's actually not bad. Let's see. So 28, 85 seems a little bit wrong. This is a little bit wrong. 85 is. I don't know if I just have to times it by n though. Or n factorial or something. Oh yeah, that actually I didn't use that. So here maybe factorial of m. Because because we actually talked about that, but then okay, so is this right? So this is right. So I think my formula is mostly right? So yeah, so we can maybe work out something like that, and then now. Okay, now we have to do the K part. Actually, this is surprisingly not bad for, good job, Larry, right? But now we have to do the K part, right? Okay, so how do we do the K part? The K part is not that bad. It's just that we treat. Okay, right? Basically, you have carry bits, right? I think that's how I want to think about it. How do I want to think about it? I mean, that's basically the idea. The carry bits. Oh, but then you have to do the math on inverse factorial and stuff. Oh man, it is so annoying. Okay, fine. I mean, remember 0 to k we're done, which is actually pretty cool. But okay. So then now we have to figure out the k bit. I mean, carry is probably the way to go, right? K left, carry, maybe something like this. Where is that? That's 30, 30. I'm trying to think whether I can do another 50 loop on here. Alright, so 50 times 30 times 30 times carry. Carry should be at most 50, right? Maybe. Okay. Okay, so tick. So this is a little bit different now. So tick, no tick. Okay. maybe I could do them in pairs, right? So tick 1. So then, okay, we tick 1, then it's just k left -1, because now we know that there's a 1 in this bit. If k left is equal to 0, and then there's no carry, right? And we can definitely take more than 2, just to be clear. But so no tick should be the same. I mean, we have to get carry into the current thing. So this isn't quite right because we're not factoring carrying in. We're just focusing on carry out. But maybe that's fine. Well, that's fine. It just it just factors into k left, I think. Yeah, okay, fine. Right. Okay, take 2 and repeat, possibly. So that here, if k, this is also if m left. Oh, I guess I didn't do this one. I think I should have, but yeah. Okay. So if m left if we still have them, then we can do okay. K left does not change, but carry. We have 1 extra carry, right? So we take 1. Okay, so then now how do we deal with carry? So that means that we carry over things, right? So then carry, we want to divide by 2, because now, oh no, well, we do eventually, but okay, what does carry mean to the left? K left, that's all it does, right? So that means that, okay, carry divided by 2, and then basically if carry mod 2 is equal to 1, then k left we decrement by 1. Well, depending on what we do, right? Okay, so then that means that parity is equal to 1, say, right? And then now here, yeah, we take 2. Wait, is this right? The thing is that we want carried forward, but this is actually messing this up because of the repeat part. Okay, it's either that or we do the max carry for like 5 things forward or something, but that's just awkward, right? Is it? No, maybe that's fine. Actually, I guess that's what this already does. But how do we do the repeat thing of the carry on the next carry while also calculating this into the parity? I guess we just have to factor this into the carry, right? So, okay. So, okay, so no tick, carry, carry just divided by 2. So that carry is updated. K left is plus carry mod 2. Okay, maybe that's how. So no tick. No, well, it's not plus. So okay, so right. So minus. Okay, fine. And maybe we have too many crazy things. So if k left is less than 0, we just return 0. Yeah. Okay, so take 1. Then you have this. Minus is minus this minus carry mod 2, I think, right? And this again is carry because we're done. Right, and then now this is fine. Kind of no, because then now when you keep on taking 2, you want next carry to be this, and then but when it ends, when you do it, then it carries back. I think the idea is right, or the approach is right. But we're definitely not doing it that way. Yeah, maybe this thing is too silly. Okay, let's not prematurely optimize this part. Let's just say we have, you know, for I in range of m left plus 1, say. Then we just have I'm gonna keep this because I'm gonna forget. But okay, for I in range of m left plus 1, we have say power of num sub index to the I power, keep it in mod power, times go index plus 1, m left minus I, k left, we have I mod 2 is the number of k left we have, minus carry maybe, minus carry mod 2, right? Okay, so k left minus I mod 2 minus carry mod 2, something like this. Carry plus, well, carry now we divided by 2 plus something like this, right? So if these are the same, I'm just trying to think actually. I think this is this. I messed up. Okay, so this bit. Okay, so bit is going to be 0. If I mod 2 is equal to 1, then the bit is going to be, well, we flip it. And then if carry mod 2 is equal to 1, then we also flip it again. So then, and then now we just, whether there's a bit on this bit, and then now carry is going to be half of that plus I divided by 2, right? Okay. And I think this is right without the factorial bit. Maybe? I don't know. Let's run it real quick. Go. I just say k and 0. In theory, this should give us the same. Oh, I guess my timer is out. That's why it gives me the expected answer. But yeah, should. I mean, the factorial part. Actually, let's remove the factorial part just to kind of see. I mean, we should be able to get. I mean, this is just wrong. But we should be able to get the right answer. But well, like this should give us the right answer if, yeah. But this is where's m left is 0 0. Okay, n carry is equal to 0. Well, n k left is equal to 0. Oh, that is okay. So I was right on this, but then now this m factorial assumes that everything is duplicate. So I mean, and now we have free answer anyway. So okay, so let's try something like what I mean is that we have a free lookup on the answer because we already time expired. So yeah, so we know that this is going to be wrong because we don't divide it by the thing. But here that's fine because this is the part where we want to divide anyway, right? So it's this times inverse factorial of I, right? Yeah. Yeah, okay, fine. But I do want to flip this to... I mean, you don't want to... I guess 0 factorial is 1, so inverse of that is just 1. So okay, that's fine, maybe. Okay, so I factorial is equal to x for... what's it called? Power to... power of what? Oh, just I factorial. So factorial of I... -1 on mod. I mean, I'm kind of writing this lazy, but it's only like 50, so it should be fine. It just be 52, something like that, right? Mod. Oh, I don't have mod outside. Okay, fine. I actually don't know how long I'm taking on this one, but okay, not right, unfortunately. Am I off by 1? Hopefully I'm off by 1. Should be like 1 1. Okay, no, this is right. I factorial is right. Yeah, 1 2 3. No, that's 6, right? So 1 factorial, 2 factorial, 3 factorial. Okay, so this is right. Ish. What does 1 bit mean? I guess this part I thought I could work out, but clearly I'm wrong. I thought it was just I factorial. Huh. I mean, it's either that or my k left is wrong, honestly, which is it wouldn't surprise me, honestly. Just make it slightly faster, but maybe I don't know how to get rid of the tubes. I was hoping that this would be right, but I mean, a lot of things could be wrong on this one, so okay, fine. That's. I do want to get lunch, so I am struggling a little bit, but okay, fine. So 1 set bit, you have 2 amps, so I don't know, 110 maybe. I don't know. I'm just trying to see where I can figure it out. So expectance is 101 because why is that? M is yeah, so it means that it is 10 and 10 and then 1 and 1, and then you sum it together, right? My answer is 1, so that's a little bit awkward. Why is that 1? Oh no, no, that should be right. This should be right too. Okay, so that's maybe telling. Let's say I remove, oops, not that. Remove just this part. So then the answer is 2. So that's awkward. So I'm missing something. That might actually be helpful, actually. Because why is it not doing 10 by 10? Okay. The 0, right? Okay, let's see. Oops. thought it would be not too bad to be. That was wrong. Okay. I mean, there's no 100 anywhere. Okay, so at 1, it should have 1, 1, 2, 1. So, okay, 1, 2, 1 is what we care about. Okay, fine. Carry is 0. That's fine. Total should not be 0. Okay, so why is it 0? What does it call? Yeah, that should not be 0. There's some optimizations we can make here for running time, but I'm just trying to do correctness, right? So everything is right except for the total. Okay, so that means let me. Alright, okay, right. Okay, so it's 1, 2, 1. So that's 0, 2, 0, 1, 2. So if this is, if I is 2, then we have 100 here plus but then I minus 2 k left minus bit. Oh, the carry is wrong because I don't. Oh no, I of 2. So that 1 is. Oh, this carries. I see. So I mean, it's okay. Maybe we're close. So then, okay. So yeah, okay. So because carry can go outside the bounds. Okay, fine. So then now, maybe I'll just do it a little bit lazy, right? Is it bit count? Right. So we don't have to. We don't even have. Okay, fine. Just skip it this way. Is it underscore bit count? Okay. Or bit underscore count. All right. Of course, we have to try random things, not just the one that we did, right? I think if this is right, I will submit it. I mean, it may time out, but oof, that's tough. Okay. I mean, I think that definitely is a thing that we had to fix anyway, but at least we fixed it for one thing, so that's good. Okay, so then why is this still wrong? Okay, let's just do 3, 1, maybe. This. Alright, let's just do this. I think this is actually impossible. I thought it would be impossible, but it's not, because you can have 1, 1. Okay, so yeah, 1. So 1 times 1 times 10 is why it's not possible. Oh, it's not impossible. So why do I get this one wrong? I think it's just 0, right? 1, 3, 1. So we want two 1s and oh yeah, well, we have to do the ordering, but 2 1s and a 10, right? Okay. So that means that this one's impossible, which is correct. This one should. Oh. Wait. So we have a carry. I think this one should be. I gotta run to meet. This video is taking too long, so I have to maybe catch lunch with someone. So maybe I'll come back. But okay. So here, index 1, M left because we use 2, so we have 1 carry. K left is 1 because we used the 1 carry. Okay, that's fine. This should be non-zero. Okay, M left. So we want to use 1. What does 1 look like? So we have a bit. 1 converts it to 1. Bit converts it to C to. There is a carry. So bit is 0. Okay, bit is 0. So this is K left is right. This is 0. Oh, I see. Okay. Okay, let's see if it's right for the other numbers, of course. Or just like this one. If it's right for this one, I'll submit it. But yeah, I'm really bad at math apparently. Okay. Yeah, it looks okay. Let's give it a YOLO submit. Submit. Ooh, yes. This is a ridiculous problem. How long did I end up taking anyway? I don't know. Actually, I mean, it's a rough estimate from the last time the last problem, because I did them back to back. I could look at the video as well, of course. But 49 minutes, that's not so bad. I think the math is definitely tricky, and I think I did it faster. I mean, actually, I'm happy with how long I came up with it. There were a couple of minor things that I had to fix with the bits and stuff, but yeah. Alright, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, I'm running because I gotta catch dinner, lunch. But okay, actually, let me do a recap real quick. Q1. Where are my recaps? Right? Did they open it in the other way? I don't know. It's so silly. Okay, fine. Let me do a quick recap before I go. Right. First one is fine, right? It's just maximum digit. Okay, no recap there. Second one also just recursive, but followed the direction, so pretty fine. Q3. Yeah, I mean, this one I just took a long time because I was. If I didn't take so long on Q3, I would have gone Q4 in 49 minutes, which still would have been really tight. I have to be like if I got in it, I don't know, you do the math, right? If I was able to get Q3 in like 20 minutes, which I really should have, I was just kind of stubborn about how to, because I don't know. Well, for this one, honestly, I didn't analyze the complexity too tightly. I was a little bit YOLO. Though now that I look at it this way, it's pretty straightforward, right? Because current is the current speed, so it's up to 100. Left, right is 50-50. And then K left is also 10. So maybe that would have been fine. But I wasn't thinking about it. As a result, I was trying to be too cute and too smart and compress. Like I was prematurely optimizing for this one. And then this one, I think it's just a grind. You saw it. I mean, I think the ideas are interesting. It's just a grind. That's all. But yeah, that's all I have for this contest. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.